wanted to show you in this quick video how to do a circuit. So we're going to be using circuits often for homework and sometimes as group work. And they're easy, it's just a little different. So the first thing you want to do is locate number 1, which is almost always one of the first problems, and complete it. So the directions say use the following table shows selected values of 3 continuous functions, f, g, h. The function h is also strictly decreasing, probably important for something later. Beginning in cell 1, use only the values in the table to evaluate the expressions for the given x values. Search for your answer, call that cell 2, and proceed in this manner until you complete the circuit. For your convenience, this table is on both sides. So there's the table here, and it is on the second page of the worksheet as well. Now when you are doing a circuit, you can either print, but if you do not have a printer, you can just use lined paper. When you use lined paper, make sure you write down the problem. And if there's a table and you feel inclined to record it, it might be helpful to have it on your other paper, but that way you don't have to keep looking at the screen. It's up to you. So anyway, we've got G5 and H2. So G of 5 is -3. H of 2 is 3 over 2, which becomes -9 over 2. And then I'm going to search for this answer. So you can see next to the problem, there's an answer right here. Then there's answers here, 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 etc. Right? So I'm just going to look for the answer, which happens to be right here. And so then I'm going to call this problem number 2 and continue. So again, with anything you do for me this year, especially while we're digital, I need you to make sure your name is written in pen at wherever you're doing. So if you're working on the circuit, you'd write it in pen here. If you're working on another piece of paper, make sure it's on pen at the top. Try not to use a erasable pen like I just did, but that way you can't just hand it to your friend who can also turn it in and take it or send them the picture or whatever like that. We want to be as authentic as possible. So anyway, I'm going to keep going and show you what happens. G of 0 is 3. F of 1 is 3. So G of 0 minus G of F of 1 is 0. And so I'm looking for the answer 0. It's nowhere on the front page. So I go to the second page, and there it is. So this is number 3. And then I would do this problem and so on until I complete the circuit. So I'll be back to show you what a completed circuit looks like in just a second. Okay, so I've been able to finish the circuit since last we talked, and you'll notice that we kind of bounce around in the numbers here. You can see all my work on the page, and then as I went forward. So some of the things that are a little tricky with, so my 16 was my final question, which had an answer of -5/4, so I completed my circuit. So that's how it works, but there were a couple of things that I kind of would like to point out in some of the things they do. So like this answer to question number 4 is pi plus 16 over 4, and I didn't actually get that answer on any problem, but I did get this answer, 4 plus pi/4, which meant I had to simplify it. So keep some of those things in mind. You'll notice I kind of did some simplifying, knowing that I'd have to for some of the problems. So just keep some simplification issues in mind. There were a couple of problems I wanted to talk about, make sure we understood, that are specific to the circuit. So if you're just trying to remember what to do with a circuit, we're done. But if you're trying to complete the circuit that was the homework on the first day of class, then you can stick around and listen to this. So 11 is what is undefined, and so maybe you do or do not remember what's undefined, and I know that last year we didn't get to rational functions in Accelerated Math 3, so you might not really remember this, but anything when you divide by 0 is undefined. So I was looking for something that would make this denominator 0, which meant that had to be 6, and so that's why I figured out it had to be 4. Okay, then the other one I wanted to talk about was this one with the words average rate of change, which again is a pre-calculus topic, meaning that you learned it before calculus, not in the course pre-calculus, but before you were in calculus. And it's called average rate of change, which is just slope. Very important that you remember that's just slope, which means you're going to take the y values at these 2 points, and basically for average rate of change we say h of x of the second, I don't want to write it that way, but basically we plug in this and plug in that, subtract them, then just do the subtraction. And you should notice that's y2 minus y1 over x2 minus x1. So just slope. Okay? And those are the two that I wanted to be sure to talk about, just division by 0 and average rate of change. circuits can be really fun. What I like about them as a teacher is they grade themselves, so you know you got everything right if you get back to the beginning. All the answers are there, but since they're messed up, it's not like, here's the answer to this question, try to find it. It's, can you find them all? So I just think that that's a pretty neat thing. So I hope you enjoyed them. We'll talk to you soon.